All right, guys, this is the screencast to help you explain a couple more examples of balancing chemical equations. So take a look at this. This is sheet number 1. This is 18 problems that you'll be responsible for, but I'm going to do maybe 2, possibly 3 examples on here, so you only have about 15 problems to do. So watch as I go through this. I'm going to go through number 1. Number 1 is one of the easier ones, so that should be a pretty good place to start, and then I'll show you exactly what's going on after that. So start with number 1. I have magnesium plus O2 plus oxygen on the left-hand side. Notice that there's only one magnesium because... Nope, okay. Notice that there's only one magnesium because there's no number after it like there is for O2. So there's 2 oxygens on the left-hand side. Typically, when I balance equations, I start on the left-hand side of the reactants and go with the first element and try and balance it on the other side. So I have a 1 here for magnesium and a 1 over here for magnesium. So that's, the magnesiums are already balanced. But the oxygen, though, I have 2 on this side, but I only have a 1 on this side. Now, we typically don't write 1s. That's why I like to erase them then. But you should know that there's a 1 unless a number is stated for you. So I cannot do that. You are not allowed to change subscripts. That is the cardinal rule in chemistry. You cannot change subscripts in a chemical equation to get them to be the same, because that changes the number of magnesium to oxygen ratio, and you can't do that. So what we can do, though, is we can double the number of magnesium oxide molecules I have. So I have 2 now, which means I now have 2 magnesiums and I have 2 oxygens. I'm actually multiplying as I go from the 2 to the 1 and the 1 for magnesium and oxygen. I multiply those numbers, coefficient times subscript, which means that I need over here, I come back to magnesium, even though they were balanced in the beginning. For the magnesium, I now have to put a 2 in front to get them to balance now. So I have 2 for the magnesium, I have 1 for the oxygen, and 2 for the magnesium oxide. You may see answers written like this, 2, 1, 2, and that just means the numbers in front. All I'm doing is listing the numbers in front of the molecules. So let's skip down here to number 3, because number 3 is a little bit more difficult than number 2 is. So I want to increase in difficulty as we go down. So I have 2 hydrogens here, and that's the only place it shows up on the left-hand side of the equation, so that's good, which means I'm going to need at least 2 hydrogens over here. So now I have my hydrogens are balanced on both sides. My problem is, though, that I have 1 times, I have 1 plus another 3 equals 4 oxygens, and 2 times 2 equals 4 oxygens. So that one actually works out pretty good. So how about nitrogen? I have 2 nitrogens here, and here I have 2 times 1, which is 2 nitrogens here. So I'm actually balanced. This one was a little bit easier than I thought it was. All I needed was a 1, and a 2 to get them to balance. So that would look like this. 1, 1, and 2. There we go. How about number 4? Now I'm positive number 4 is a little bit more difficult. So let's take a look at number 4. So I got Na2O plus H2O yields NaOH. So I know automatically I'm going to have to put a 2 in front. That's to get the number of NAs and the number of NAs to balance. Okay, so now I have 1 plus another 1 equals 2 oxygens, and here I have 2 oxygens. Okay, so that works out pretty good. So here I have 2 hydrogens and another 2 hydrogens. All right, well, these were not as difficult as I thought they would be, so let's move on to something that looks even more difficult. So let's get down to the good stuff here. Oh, here's a couple of good ones. That is so not cool. Yep, okay. Everybody wants to do number 13 because it's the longest one on here. So let's take a look at number 13. Here I have Mn and Mn, and they're balanced. Here I have O2, and there's 2 of them, so I need a 2 in front over here to get 2 oxygens. Now that means I have 2 times 2 that means I have 4 hydrogens. So to get 4 over here, I put a 4 in front. That now gives me 4 hydrogens and 4 chlorines here, and I have 2 plus another 2 here, which equals 4. I think we're balanced, actually. Okay, that was pretty easy. So I got 1, 4, 1, 1, 2. So that's a 1, 4, 1, 1, 2. Okay, super easy. All right, I want you guys to try a bunch and see how it works. Make sure that when you're balancing, you keep your polyatomic ions the same. If you see it on both sides unchanged, then you can keep them together in one thing. As in NO3, there's only 1 of them here, and I have 2 over here. So I would do a 2 here, and then probably another 2 over here to get the N. Okay, so, all right. That's my example for sheet number 1. I went through a bunch of problems.